Right now, in a desert in China, there is a machine running quietly that most scientists said could never work. It does not use the same fuel as every other nuclear plant on Earth. It does not need to shut down every year like normal plants do. And the material powering it is something so common, you have probably touched it without even knowing it. This machine could change how the whole world makes power. And the strangest part is, the fuel behind it was sitting right under our feet the whole time, ignored by almost everyone for almost 100 years. Scientists tried and failed to build this exact kind of reactor for almost 70 years. Some of the smartest engineers in the world gave up on it completely. So how did China finally pull it off? Let's start from the beginning. If a video like this helps you understand big science stories without all the boring parts, hit subscribe now. We break down stuff like this every week, and some of the videos coming up are even wilder than this one. A metal hiding in plain sight. Most nuclear plants today run on a metal called uranium. It is rare, it is expensive, and digging enough of it out of the ground takes a lot of work. But there is another metal that is way more common. It is called thorium, and it shows up almost everywhere. It is in sand on beaches. It is in deserts. It is in riverbanks all over the world. Some countries have giant piles of it just sitting next to mines, completely unused, because for decades, nobody knew what to do with it. Here is the strange part. By itself, thorium cannot power anything. It just sits there, doing nothing, like a candle with no flame. You could pile up a mountain of it and never get a single spark of energy out. But if you hit it with something tiny, smaller than you could ever imagine, it changes. It turns into a brand new metal, one that can burn and make heat. It is almost like the thorium was asleep the whole time, just waiting for something to wake it up. That single trick is the reason scientists have chased this idea for decades. Turning a useless rock into real fuel sounds like magic, but it comes with a huge problem. And that problem is exactly why nobody built a working reactor like this until now. Why regular nuclear plants keep breaking the rules. To understand why this new reactor is such a big deal, you need to know how normal nuclear plants work. Every regular plant uses solid metal rods packed full of fuel. Those rods sit inside thick metal tanks, and water rushes past them to carry the heat away. That sounds simple, but it is not. To keep that water from turning into steam, plants have to squeeze it under massive pressure. Think of a soda can squeezed so hard it could burst at any second. That is close to what is happening inside those pipes every single day. We are talking about pressure so strong that the walls holding it in have to be a foot of solid steel. And even with all that steel, the fuel rods still wear out. Every year or two, workers have to shut the whole plant down, crack open that heavy tank, pull out the old rods, and load in new ones. While that is happening, the plant makes no power at all. It is slow, it is risky, and it happens at nuclear plants everywhere on the planet again and again, decade after decade. On top of that, those old rods do not just disappear. They stay dangerous for thousands of years, so they have to be buried deep underground and left alone for longer than most countries have even existed. Scientists have known for a long time there had to be a better way. They just could not figure out how to build it. The machine that never stops. This is where it gets interesting. Instead of solid rods, China's new reactor uses a fuel that is already a liquid. Picture salt, but melted down until it glows and flows like lava. The fuel is mixed right into that liquid, so it never needs to sit inside a solid rod at all. Because it is already a liquid, this reactor does not need to be squeezed under crushing pressure like a normal plant. That alone makes it far less likely to ever explode. But the real jaw-dropping part is what happens when it needs more fuel. Since everything is already liquid and flowing, workers do not have to shut the reactor down at all. They just add more thorium straight into the mix while the machine keeps running, kind of like topping off your gas tank while your car is still rolling down the highway. No other reactor on Earth had ever managed that. China's machine did it, and it kept working perfectly the whole time, without a single hour of shutdown. This new machine also does not need to sit next to a river or an ocean. Normal plants need huge amounts of water just to stay cool. But this reactor runs so hot that plain air can cool it instead. That is exactly why China built it in the middle of a dry desert, far away from any major water source. A spot that would be useless for a normal power plant turned out to be perfect for this one. There is even a clever safety trick built into the bottom of the tank. A fan keeps a small plug of salt frozen solid, blocking the bottom like a cork. If the power ever goes out by accident, that fan stops spinning. The plug melts on its own, and gravity pulls all the liquid down into a safe tank below. The whole reaction shuts itself off, with no buttons, no workers, and no emergency alarms needed. A world powered for 1,000 years. Here is the part that should really blow your mind. Thorium is so common that experts believe what we have already found could power the entire planet for over 1,000 years. Not one city, not one country, the whole planet. Because this new type of reactor does not need rivers or oceans to cool it down, it can be built almost anywhere, even in the middle of a dry desert. That means places that never had a real shot at nuclear power before, like desert nations or dry mining regions, could finally build their own. Some engineers are even talking about putting small versions of this reactor on cargo ships, so massive boats could cross oceans for years without ever stopping to refuel. Others are dreaming even bigger, using the extreme heat from these reactors to help make clean fuel for cars and factories, without burning a single drop of oil or gas. Right now, this reactor in China is still small and experimental. It is not powering cities yet. But every single day it keeps running. It proves this wild idea actually works in the real world, not just on paper. China is already planning a bigger version, 5 times the size, and construction could finish before the end of this decade. Big ideas like this usually move slowly at first, then all at once. This might be the slow part, right before everything speeds up. If you made it this far, you clearly love learning about wild science stories most people never hear about. Hit like, subscribe, and turn on notifications so you do not miss the next one. We have another video coming up about the race to build reactors small enough to fit inside a shipping container, and it is just as crazy as this one, maybe crazier. So here is my question for you. If reactors like this really do become common in the next 20 years, what changes first? Deserts, ships, or something nobody is even talking about yet? Drop your answer in the comments.